First thing we're going to write down is some expressions for common terms. Okay, we're going to start off with any number. 17.8 algebraic proof. Any number. Any number could be represented by a letter. So for instance, if I use the letter X, that represents any number. It could be 1, 2, 3, 4, 5, any integer. Okay, so X or any letter, N, it doesn't really matter what they use. I'll just go with X here. Okay. Quite commonly, they actually use N, so maybe I should use N. Okay, let's use N. Any number, N. Now I want to talk about an even number. Why 2n? Someone said 2n. If you multiply any number by 2, it will be an even number. Is that the case? Yeah. If you multiply anything by 2, that means 2 is a factor of it. And if 2 is a factor of a number, 2 goes into something, it must then be an even number. And also, if you look at 2n, can we factorize 2n? This is an expression. Can we factorize that? We can write it as 2 bracket n, which means 2 is a factor and n is a factor. And if 2 is a factor, it implies that if 2 is a factor of a number, it means it's an even number. Okay, so I've written as 2n here, and this is just kind of more for explanation purposes. This bit here, the 2n that I've written in a factorized form, so I'll just keep it here separate in red. So that's indicating that 2 is a factor of 2n. Therefore, so therefore is usually denoted by 3 dots. I was just using shorthand here. Therefore, 2n is an even number. So if we know 2n is an even number, it's actually quite easy to write down what an odd number is. If you have an even number, how do you find an odd number? 2n plus 1 or 2n minus 1 would get you an odd number. Because an even number is 2n, therefore an odd number is add 1 to it. Okay, so we've written an even number algebraically, we've written an odd number algebraically. Any number would be represented by n. If I then talk about consecutive even numbers, the word consecutive means one after the other. We need to think about consecutive. Number examples would be 2, 4, 6. They are consecutive even numbers. But we need to think about algebraic representation, consecutive numbers, consecutive even numbers. So let's start off with our first one, 2n. The next one would be 2n plus 2. Because to go from one even to the next even, you add 2. Did you get that? You can also do 2n minus 2. And then the next one would be 2n plus 4. They are consecutive even numbers, dot, 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 dot. We can also do consecutive odd numbers. Same idea, you start off with one of the odd numbers. Let's start off with 2n plus 1. What would be the next one? Yeah, add another 2 to it. And if you add 2 to this, it gets you 2n plus 3. Because 1 add 2 gets you the 3, yeah? And then 2n plus 5. You get the idea, dot, 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 dot. You can have ones before it as well. You can have 2n. What would be the one before 2n plus 1? Yeah, if you take away 2 away from it, you get 2n minus 1. So we know how to write consecutive even numbers, consecutive odd numbers. But what if they ask you to write down any 2 even numbers? Any 2 even numbers. When they talk about any 2, they're not talking about consecutive. They are referring to any 2 even numbers. So I could say 4 and then I could say 14, 4 or 24, 4 or 36, anything. So how would I write any 2 even numbers? Well, one of them would be represented by saying 2n. What would be the other one? But then 2n plus 4, if I write 2n plus 4, then I'm saying 2n plus, I'm talking about one number and not the next number, but the one after it. Then I'm talking about consecutive even numbers. Not times in means I'm timesing something by 2. I'm saying an even number and 5 times the even number. Not squaring, none of those. No, then I'm saying the 20th even number. I'll put you out of your misery. Any two even numbers is represented whenever they say any two, not next to each other or anything, any relation, any two. Without any relation, you would use a different letter to represent it. 2n and 2m, for instance. You have to introduce a different letter. Make a note about that. When they refer to any two, where there is no relation between one and the other, you have to call it a different letter. (2n plus 1), absolutely. So here we've got 2n, and then we've got 2m. So they are any two even numbers. Okay, so a note: different letters are used to represent numbers that have no links to them. Yeah, i.e. it's not consecutive or it's not the 5th one. Also, numbers that have no links to each other, with no link to each other, i.e. they'll usually word the word any two numbers. What if I said any two numbers? What would I call them? N, M. Exactly. You can use any letters. I've just used N and M. So since we know how to write even numbers, because 2 is a factor of an even number, how would I write down multiples? Multiple of 3. Yeah. Okay, I'll have to check it later. Which spreadsheet? The data. Okay, Juveria played with this yesterday. I'll check it. Multiple of 3. Very good. Why 3n? Because 3 is a factor of it. Therefore, it's a multiple of 3. Get the idea. So likewise, multiple of 5, 7, and so on. As long as you can write something as a factorized with 3 as a factor, it would imply that it's a multiple of 3. Okay, so that's a very important point to make. If something can be factorized, and if 3 is a factor of it, then it is a multiple of 3. If 3 is a factor, then it is a multiple of 3. Something else to understand. This is looking at the kind of grade 8s, grade 9s. Sometimes they will say there are 2 consecutive numbers. If you have 2 consecutive numbers, one of the numbers must be a multiple of 2. Does that make sense? If you have 2 consecutive numbers, 3, 4, one's going to be an even number. If you have 3 consecutive numbers, one of them is going to be a multiple of 3. If you have 4 consecutive numbers, one of them is going to be a multiple of 4. Does that make sense? Because the 4 times table goes up by 4 each time, right? If you've got 4 numbers next to each other, surely one of them has to be a multiple of 4. You can try it. 3, 4, 5, 6. 4 is a multiple of that. You can try 4, 5. 4 is a multiple. 8 is a multiple of 4. So whenever you have 4 consecutive numbers, or however many consecutive numbers there are, one of those numbers is going to be a multiple of however many of those numbers you have. So I think the best way to write that is using an example. 3 consecutive numbers will always have a number which is a multiple of 3. 4, same, will always have a number which is a multiple of 4. 5, 5, etc. Okay. How about writing a square number? Let's talk about square numbers. Square number. Any idea? N squared. What about two consecutive square numbers? Consecutive square numbers. Not any, I haven't used the word any, I said consecutive square numbers. So the first one, if I call it n squared, what will be the next one? No. 2n is you're multiplying by 2. No, then you're talking about any. Any. I haven't used the word any, I said consecutive square.
N squared plus 2.
No, then you're saying n squared plus 2 is not a square number. Okay, I'll give you a little hint. Okay, if something has a square on it, okay, let's think about if n was 1, then that would be 1 squared, right? What would be the next square number? How do I go from 1 to 2? No, how do I go from 1 to 2? Plus 1, right? How do I go from n to the next consecutive? No, how do I go from n to the next one? Thank you. Say that again. What's the next one after that? These are consecutive square numbers. Does that work? 1 squared. The next one would be 2 squared. The next one would be 3 squared. You get the idea. 1 squared is 1, 2 squared is 4, 3 squared is 9. So when you want consecutive square numbers, there has to be a square on it. So really, square numbers are any expression with a square on it. Okay? If you can get any expression with a square on it, it is classed as a square number. Anything with a square on it, it's a square number. It has to be the whole thing. The whole thing, the bracket, the whole expression has to have a square on it for it to be a square number. So if I wrote down something like this, e.g. 5x plus 3 plus y all squared. Look at that, 5x plus 3 plus y. I know it looks a bit messy, but there's a bracket with a square on it. What is that? It's a square number. That's a square number. Okay, because it's got a square on it. What am I doing? I'm doing 5x plus 3 plus y times by itself. Surely I'm going to get a square number. Yeah? So anything with a square on it, whole thing with a square is a square number. Would this be a square number? Does the whole thing have a square on it? No, it's got 2 square numbers added. Two square numbers, you've got 2 square numbers being added, but does that give a square number? Not necessarily. Think of an example. Square number 1, square number 4. Add them together, 5. Is that a square number? No, not a square number. Is this a square number? Yes, square. So these are examples of squares and not squares expressions. So we've got square numbers, consecutive square numbers. You get the idea how to write cube numbers. It's the same idea. It would be, yeah. For this, I think some of you are discussing why this is not a square number. You can discuss it like this: 1 squared plus 3 squared. That gives you equals to 10. Not a square number, is it? We're going to look at that in a moment. So it's really important, first of all, to know how to write things using algebra, which is the most important thing. The rest is actually relatively straightforward, as we'll see.